Section 6.1 is going to be over composite functions. So basically what we're going to talk about is a composition of a function. Now it's a new operation we're adding to functions. We have addition, subtraction, multiplication, and division, and we talked about all that back in chapter 3. Now we're in chapter 6. We have a new operation we're going to add, and that is composition of functions. The root word here is composition, so you would compose two functions together. They're made out of each other. So with a function, we can always plug something into a function. So for example, if I have 2x, or f of x equals 2x plus 1, if I want to find f of 1, that's 2 times 1 plus 1. If I want to do f of 2, that's 2 times 2 plus 1. Whatever's in the parentheses replaces the x in the function. Say I have f of n, that is going to be 2n plus 1. F of k, 2k plus 1. F of n plus 1, this is going to be 2 times n plus 1 plus 1. Okay, so on and so forth. So if we plug in another function inside there, it's going to be 2 of that function plus 1. In this case, g of x could be a whole nother function. So that's what a composition function is. It's plugging a function into another function. So here's the definition. Given two functions, f of x and g of x, the composition is f, and this is read f composed of g. Now the definition is, f of g of x, sorry. The definition is to plug the second function into the first function. That's all there is to it. So here, let's work some examples. Let's say I have f of x is 2x squared minus 3, and g of x is 4x. If I do f composed of g of x, that is f of g of x. So first, I'm plugging g of x into f of x. So that's going to be 2 times g of x squared minus 3. Literally take g of x, or x, and replace it with a g of x. Okay? Then let's change out g of x for what it is. So do it in 2 steps. Put g of x in on that step. Let me do that in red. Replace x with g of x, and then on the second step replace g of x with the function part. In this case, g of x was 4x, so we replaced it. So if we go on to simplify this, square, whoops, that was wrong. Pardon me. And then that becomes 32x squared minus 3. Okay? Let's do another example. Let's say I have f of x is equal to x squared plus 3x minus 1, and let's do g of x is 2x plus 3. Let's first find f composed of g. That is f of g of x. Okay, so that's going to be g of x plugged into f of x, which is going to be g of x squared plus 3 times g of x minus 1. So it's going to be 2x plus 3 squared plus 3 times 2x plus 3 minus 1. So if I go ahead and distribute everything out here, this first part becomes 4x squared plus 12x plus 9. Distribute this 3, that's going to be 6x plus 9 minus 1. So this guy is 4x squared plus 18x plus 17. Now, what about going the other way? What about G composed of F? Is that going to be the same thing? Well, let's look. Let's go ahead and do G composed of F. That is G of f of x. So that's 2 times f of x plus 3. So 2 times x squared plus 3x plus 1 plus 3. Distribute the 2. 2x squared plus 6x plus 2 plus 3. Oops, running out of room. We get that. 2x squared plus 6x plus 5. Now, that shows me, looking at this one and this one, they are not equal. So that means that composition is not commutative. So you cannot always assume that it's going to be the same. Now there is special cases where you can come up with where they'll be the same. And again, those are just special cases. Okay?